Hello wonderful person, this is Anton, and today we're going to be talking about coronal mass ejections and extremely interesting research coming from Japan that suggests we may have found a way to predict extremely dangerous coronal mass ejections. But I also wanted to connect this to another video I made previously about the coronal mass ejection event that's most likely going to really disrupt our society. So let's talk about this, and welcome to What the Math. This is actually a video NASA released a few months ago that's called The Decade of Sun. And what this shows you are the pictures taken by NASA over a period of a decade, and it basically shows you our sun for this entire decade. This is what our sun looked like for about 12 years. But it's also kind of important to understand that in the last decade, or actually even 2 decades, we got super lucky. For some unknown reason, our sun suddenly became a little bit more quiet, and at the same time, the events that normally cause a lot of disruption on the planet, specifically here we're talking about the electromagnetic storms that usually form on the surface of the sun as the result of a kind of a magnetic entanglement that you're going to see here in a few seconds, normally occur quite regularly, at least a few times per decade. But in the last 2 decades, we only had one potential event that could have hit planet Earth, but missed us by just a little bit. The most famous such event is the so-called Carrington Event that occurred back in the 19th century, and actually back then, even though we didn't have much technology for this to be affected by, it resulted in serious damage to the newly installed telegraphs. So if this were to happen today, it would most likely cause tremendous damage to our society. And we're not just talking about satellites, because as you can see here, these CMEs, these coronal mass ejections, are very powerful. They affect the actual surface of the planet as well, and as I've discussed in one of the previous videos, certain CMEs can even potentially cause earthquakes on the planet that do actually cause physical damage. So in that sense, knowing when the CMEs occur, or even trying to prevent them, is sort of important. But going back to the fact that we got lucky, in the last 20 years there hasn't been a single CME that was damaging enough. And remember, in the last decade or so, that's essentially when our technology became pretty much widespread. We have smartphones everywhere, we have pretty much everyone using laptops and computers, and all of this technology, everything we're using today, is not CME proof. All of it can be pretty much shut down almost instantly if a CME occurs and if it causes a tremendous damage on the planet. And so being able to predict these events, or preferably even prevent them, is something a lot of scientists are currently working on, because they're all certain, and actually I would agree with this, that CME is inevitable. It's going to hit our planet in the next decade, almost for sure, and when it does, it's going to create havoc everywhere, mostly because we're just not ready for it. So being able to predict it is really important. But first, this really important message from NASA. Flares and CMEs are not the same. When you hear someone talk about solar flare, that's not really at all what we're talking about in this video. CMEs are coronal mass ejections, and these are, as you can see, giant clouds of particles that are hurled toward our planet that usually take approximately 3 days to reach planet Earth. And these are the ones that are very dangerous for our technology. Flares, on the other hand, happen really frequently, only take about 8 minutes to reach us, and these are usually very highly energetic rays, such as X-rays for example, that, well, they're dangerous for our upper atmosphere and for possibly astronauts living in space, but not so much for anything on the planet. So CMEs and also flares are basically not the same, and CMEs are the dangerous ones. But sometimes flares and CMEs can occur together, such as in this example right here. Either way though, CMEs are the dangerous ones, that's the ones we are trying to avoid. Flares happen quite regularly and are not too bad. But now let's talk about the paper and what they've discovered. So last year there was actually research suggesting that it was extremely hard to predict these events. These were just like predicting weather. It's statistical but not so much physical. But the scientists behind this paper were able to kind of disprove that. They were able to find the physical or the physics-based explanation to how CMEs form and to how we can potentially predict them in the future as well. And most interestingly, their technique is able to predict where the CME might occur and how powerful it might be as well. But to try to predict the formation of CMEs, we also need to first understand what's going on here. Today we think that, or we strongly believe that, the way that CMEs form are the interaction between the solar spin, solar rotation, and the way that the magnetic lines inside the sun form naturally. And this very simple simulation kind of shows you what might happen inside the sun. As the magnetic lines get more and more entangled, eventually some of them snap. But at the same time, the question here is, why is it that certain ones snap but certain ones don't? In other words, how can we actually predict if this one, for example, snaps as well, or if it's just going to return back to normal and disappear with time? And so this is what the scientists behind this paper wanted to investigate by looking at the physics behind the formation and the snapping of these magnetic lines. And the first thing that they realize here is that, well, for the magnetic lines to reconnect or to snap, something else must be controlling this in the outer parts or the outer regions of the sun. So they believe it has something to do with the solar corona. And their finding here is that when the coronal magnetic field is weaker in a certain region above the entangled magnetic lines, it does have a higher chance of snapping in this region and thus creating the CME. Whereas when the coronal region was much stronger magnetically, it would prevent the magnetic lines from snapping, from reconnecting, and thus prevent the CME from forming. And they also realized that most of the CMEs, if not all of the CMEs, occur exactly when the magnetic lines right here become almost parallel to each other. And the reconnection usually happens when something disturbs these parallel magnetic lines and causes them to, well, snap. This apparently leads to a runaway effect where a lot of energy is suddenly released and the entire region is destabilized. And so to try to predict this, the scientists took two steps. For the step one, they decided to measure the magnetic field around the sun, identifying areas where the magnetic field over certain sunspot regions were not as strong as over certain other regions. They used various 3D computer models of the sun's magnetic field to try to estimate the most likely places for these magnetic field lines to snap. And for the step 2, they took the observations from the magnetic field lines and tried to estimate the amount of twist in the magnetic field lines, comparing it to the strength of the magnetic field above those lines. In other words, they wanted to see how likely these lines were to snap if a little bit more magnetic force was applied to them. And for their calculations in the magnetic field reconnection, they came up with a kind of a value known as kappa, which would define how likely this were to happen, how likely were these magnetic field lines to reconnect, which surprisingly also allowed them to calculate the potential force of the CME as well. So not only were they able to predict the CME, they were also able to predict the potential force of this event as well. And when they tested their results on approximately 200 different dark spots that were visible on the sun between 2008 and 2019, they were able to very accurately predict 6 out of 7 potential events that would have been quite dangerous if they hit planet Earth. And they were able to do so approximately 24 hours before these events would have hit planet Earth as well. And in their calculations, there were only 3 out of 200 false positives, meaning that the system suggested that there would be a CME, but nothing ever happened. In other words, the accuracy was actually pretty good. And in one of the previous videos, I've also mentioned that these large CMEs are also potentially connected to some of the largest earthquakes on the planet. So by being able to predict powerful CMEs, we might also have a few days to prepare for a powerful earthquake somewhere on the planet. In other words, this is actually really important research that might allow us to predict some of the most powerful events that could destroy a lot of communication and, of course, infrastructure on the planet. But until further studies and until further analysis, that's kind of all we know for now. It's definitely very important research, especially as the years go by and as more and more technology is being used around the planet. For now though, we just have to be careful. A CME of any proportion will be very devastating to many different devices on the planet, and we have to be ready for it. Anyway, once we learn more, I'll make sure to follow this up with another video. Until then though, thank you for watching, subscribe if you still haven't, share this with someone who loves learning about space and sciences, and maybe come back tomorrow to learn something else. Maybe support this channel on Patreon, and maybe support this channel by buying the Wonderful Person t-shirt you can also find in the description below. I'll see you tomorrow. Space out, and as always, bye bye.